I think it is about time that we start. Welcome to this session. And in this session, what we would like to do is present to you the Delft ICAI labs. And Delft University of Technology, large university, a technical university with 25,000 students and a lot of activity going on in the engineering sciences. At the moment there are 3 labs that are ICAI labs, and we would like to share a bit with you about that. Let me start. So here is the first one. This was started in 2019. I think it was lab number 5. This is a lab together with Ahold Delhaize, and this is one of the 2 ICAI labs with Ahold Delhaize. It's a lab that focuses on robot technology. There are still 2 people waiting. They are entering now. Okay, welcome everyone. The host has asked you to start the video. Oh, sorry, I started too fast. Let me do a restart. So here I am. Welcome everybody. Good afternoon. My name is Arie van Deursum. I have a camera and I forgot to switch it on, but now it's on. In this session, we would like to present to you the ICAI labs of Delft University of Technology. And there are 3 at the moment. One of them is the AI for Retail lab, Air Lab Delft. And that's a lab together with Ahold Delhaize. It is one of the first, number 5, the 5th ICAI lab. And it focuses on using robot technology in shops like Albert Heijn, for instance, to help with filling, to help with maneuvering goods through the shop, etc. This is a lab that is based in the TU Delft Robo House, where different startups and all sorts of companies together and academic students work together on all aspects of robotics. So this was a lab from 2019. A lab from 2020, the next year, is AI for FinTech research. And what we decided is today that we'll focus on this lab in more detail. So after my short introduction, there will be a lot more detail about this AI for FinTech lab. So I'm not going to say too much about this myself. And then the 3rd lab that was actually started this year, or strictly speaking, end of last year, is AI for Bio. And this is a new lab with DSM technology, focusing on 2 areas. One is digital twins for several aspects of activities where DSM is working on: smart plant scheduling, large-scale fermentation, and lab automation, self-learning. So this is about creating digital twins of things that are going on in plants in order to help with the scheduling. And applying machine learning for all sorts of, well, biocomputer science problems. This lab really just started, so there's not much to say about it. So here, the lab with Ahold Delhaize is really up and running. The FinTech lab is almost complete in terms of running, and this one has just started. My last slide. So AI at Delft. On the one hand, it's a core discipline, of course, in computer science. So we work in Delft in areas like deep learning, vision, evolutionary computing, reinforcement learning, and those types of topics. At the same time, TU Delft recognizes that AI is necessary in all engineering fields these days. So for that reason, TU Delft launched something called DILabs. 24 of them, transdisciplinary labs in which multiple faculties work together in the area of AI to apply AI in aerospace, in architecture, in civil engineering, and those types of things. And of course, TU Delft is a university which really embraces working with industry and society, and societal partners. We do this in many different ways with small companies and small consortia, but we also love doing this in larger collaborations, and those typically are some of the ICAI labs. So we are very happy with these 3 current ICAI labs. And as Delft, we are proud to be part of this ICAI, and we are congratulating ICAI with this 3rd birthday. So happy birthday, ICAI. So in the rest of the meeting today, what we plan to do is present the FinTech lab a little more. So I will stop sharing and then Luis can take over. Meanwhile, maybe let me say that questions are very much welcome. So if you want to say something or ask something, please do so, raise your hand, if you raise your hand, I will give you the floor. And if I don't see you, just start shouting and that should also be fine. So please feel free to ask questions about anything that we do. We would love to interact with you. Okay, thanks everyone. And now the floor is to Luis. And don't forget to put on your camera.
I think my camera is on.
Yes, it's working, yes.
Right, hello everyone. Thank you for joining my favorite breakout room of this event. Hope you're having a good time. I'm indeed introducing AFR, AI for FinTech Research. And if you haven't, please take a look at our Twitter, the AI for FinTech, for updates and for any kind of interesting news about this lab. And this lab is indeed a collaboration between TU Delft and ING. So the main idea is we have all these brilliant students and researchers at TU Delft, and we have ING, this really interesting context on FinTech with 38 million clients, 54,000 employees, from which 15,000 IT employees. So they are facing a digital transformation and we want to be part of it. So what does it mean? It means that we are somehow bringing all these different research areas together, software analytics, data integration, serverless machine learning, deploying at scale, continuous experimentation, AI-based quality testing and security, trustworthy AI, reinforcement and learning, and in regulated domains, NLP and information retrieval. So we are bringing all these areas together in the context of FinTech. That means that we have all these different people, all these different experts thinking together on how to embrace this digital transformation and how to scope all these different fields, which is really, really exciting. Not only these people, but we have many, many more students that are also working together. So this is a really, really nice place to do research. And of course, now we don't meet in person that often, but you can see that we have really nice atmosphere. You can see these pictures that we were meeting together, talking about it. Now we also do it via Zoom. We have weekly meetings to discuss these topics, and so it's a really, really nice thing that we have this ICAI lab with ING. So I'm really, really excited about it. And this is what I wanted to talk about AFR. Don't forget to follow us on Twitter. Ari, maybe if you can, it would be nice to share the lab website so that people can learn more about all these different tracks that I was mentioning here. What else? Happy anniversary, ICAI. And back to you, Ari.
And I think the next one presenting is Asterios Katsifoudimos. So now we have 3 presentations focusing on some of the ongoing work in ICAI, in the AI for FinTech lab. Asterios, the floor is yours.
Thank you. Can you all see my screen?
Yes.
Excellent. So this is Asterios. I'm an assistant professor at TU Delft, and I work on various aspects of data management. Today, I'm going to talk to you about data integration in ING and what we have been up to for the last year, more or less. Long story short, it's very common to talk to data scientists and to AI and to data-driven decision-making, but everybody reports the same exact thing, that before you are able to do anything with your data and build any models and do any fancy deep learning, you first have to basically discover, integrate, and clean your data. Okay, and that is basically let's say if you have a pyramid of needs for AI, that stands almost in the bottom of the pyramid, in the base of the pyramid. Now I'm going to focus mostly on integration, not on cleaning, but a bit also on discovery. So everybody, when they have in mind the data lake, they think that there's this very beautiful place where everybody puts their data is clean, nice, beautiful, integrated, and you can simply go in there, pick some data points and draw a model using those. But the reality is that everybody dumps data in a common data repository in the best case, or everybody is siloed behind their own, let's say, Teams structure, and the data lies within very different teams inside the company. Now, traditionally, the problem has been approached as follows, that you will gather all of your data sources, you will build a global mediated schema of everything, and then all you have to do is do machine learning or querying and reporting and monitoring on top of the global database schema, which actually is very far from reality, because we have been trying to do that for 30 years and we have failed, for the main reason that nobody will ever agree on one global mediated schema, except within the boundaries of a specific team and a specific application use case. So everybody else needs to simply have access to that data lake and retrieve the data that they want on demand in order to build a model or whatever they want to build. So a more modern approach basically to data lakes is that you have disparate data sources that lie wherever in the company, and you ingest those data sources, you store them, you perform data cleaning, data augmentation, discovery, and on top of those, you build knowledge, you build semantics. For example, what does this column mean versus what this other column mean? Then you can do your reporting, analytics, and build your ML models. Okay, now within this context, let's say the modern data lake approach of data integration, we are trying to basically tackle the problem as follows. We try to basically look at all of the matching techniques that have been proposed in the last 20 years and to see what actually works in practice. And we have used both datasets that are open and also datasets within ING. And this has taken multiple master theses. So basically, what is matching in this case? You are given an input dataset, and then you're given a data lake. And the goal is to find other datasets with which your original dataset can either join with, it can be unioned to basically create a bigger table out of something, or you can basically take some columns from the other tables and stick them into your original table. Now, why would you do that? If you want to build a model, for example, that has multiple features, those features have to be retrieved from the data itself. And if you think as every feature being a column in a database, for example, you have a client that has the neighborhood they live in, their income, the type of car they are using, and you want to give them an insurance, most probably you will have to retrieve all of this information from multiple places from around the company. So this is what we call the problem of data discovery. And what we have been doing with ING since basically last year, and the paper was presented yesterday at the International Conference of Data Engineering, is to try not only the traditional methods of schema matching that have been proposed in the past, but also the most recent AI-based ones, and see what works best. Only to realize that basically, more or less, nothing works well, and that we are far and comfortably far from having very efficient solutions to that problem. Now we continue in this direction and looking at how we can use graph neural networks in order to basically build on existing relationships that we know of within columns and datasets inside the company, and to generalize those to more relationships. If there's anything you want to ask on it, just stick around. The second thing that we are dealing with at ING is the following. There's a lot of data streams lying around in the company. What does this mean? There are data streams coming from, for example, log files from applications, monitoring tools that are running constantly 24/7 in order to gather data from data centers, from machines running, applications running, metrics from the website use, etc., etc. And what you want to do with those is basically you want to identify an entity that spans multiple data streams. For example, if you want to find the name of a given machine and how this has affected an error that is being reported into your dashboard, you want to find this machine in multiple different departments, but this machine will have different names and it will be represented in a different way in every single department. So what we are trying to do here is we are trying to build embeddings and basically multidimensional representations of those entities, and then try to detect those across multiple data streams in real time so that this can be used for monitoring. Okay, so these are basically the two biggest examples of what we are doing with ING. So at the moment, as I told you, we are working on schema matching with graph neural networks and on real-time embeddings-based entity resolution, which transforms basically into the problem of joins. You can get to me later. Okay, and long story short, this is the team. Noteworthy things here are that both Andra and Kyriakos started at ING as master students, and we are very happy to have them now as PhD students, and they have performed part of the work in the schema matching. Christos is working at TU Delft on the graph neural networks and schema matching, and George is working on entity resolution, backed by a bunch of other folks, both from TU Delft and from ING. So if there's any questions, I'm here to answer them. Thank you.
Wonderful. Thank you so much. Yeah, so if anybody has questions to ask, experiences with data integration you would like to share, or the role of data integration in your AI experiences, please go ahead. Please ask, raise your hand. Meanwhile, as Asterios emphasized, the master students play a crucial role in this lab as well. So I'm very happy that now we have two master students who are going to present some of their work. And Manisha will be the first. So Asterios, maybe if you can stop sharing, then.
Yeah, and Hubert had a question.
Hubert has a question. Wonderful. Hubert, ask the question, please.
Yes, thank you very much. Wondering, at the beginning of the presentation, you mentioned that there's also work in Delft done on the topic of trustworthy AI. I was just wondering, could you maybe a little bit elaborate on that topic? And who's working in Delft on that topic?
So in Delft, that is Cynthia Lim is working on that, and that this will be related to fairness in machine learning and that type of stuff. This track is about to start, but if I'm not mistaken, even Manisha will tell something about this as well. So I think the next 4 minutes will also be relevant here.
Okay, thank you.
Other questions? Manisha, the floor is yours.
Hi, everybody. Can you hear me and see my screen?
Loud and clear.
Okay, perfect. So I will be talking a little bit about my work, which is towards requirements engineering within fairness and machine learning. So as machine learning applications become more popular, what we see is that actually the industry really struggles with providing fair solutions and non-discriminatory solutions with these applications. And that obviously is not very good. So for example, there was a very popular real-life case study, which was based on Compass. So Compass was basically a model being used within the prison system to see if people were more likely to reoffend again or not. So when we initially look at the model, what we see is that for Black defendants and white defendants, the accuracy rate is pretty much similar. So we can say that, okay, the model seems fair. But when we look a bit further into the model, what we see is that actually what is happening here is that Black defendants are more likely to get a false positive, so an incorrect evaluation that they're going to reoffend, whilst white defendants are more likely to get a false negative, which means an incorrect evaluation that they're not going to reoffend. So clearly there is unfairness here. So to solve unfairness, what is being done right now is that tools are being developed and research is also being conducted. And most of it is directed towards the developer, so a data practitioner or someone who's coding these models. But the issue is that while these developers may have all of this technical knowledge, they lack understanding on what the high-level objectives are. For example, very simple questions like what even is fairness in this, in this context? And there are so many techniques to mitigate bias. Which ones should they use? Are they doing and performing the right type of tests? And there are obviously trade-offs involved. For example, fairness comes with a price on accuracy. So what are their prioritizations and also social implications of this? So as a developer within the industry, the most common thing you would do is go to your business person, right? Now, the business person speaks a different language than the developer. So what they might struggle with is explaining what their definition of fairness is in a clear way to the developer with enough information that the developer requires. And they might just harbor a lot of misconceptions. For example, they might think that, oh, why don't you just remove race? Just don't consider race within the data and then the problem is solved, right? But this is obviously not the case. So, of course, developer and a business person are just two stakeholders. Within the industry, there are multiple stakeholders. So one of the contributions or one of the things that we're trying to do is kind of identify this complex communication system. These stakeholders, what they're trying to do, and where the gaps are, what the trade-offs may be. So with this information, we can go towards a more meaningful requirements engineering for fairness. The second part of this, our work is basically to facilitate this kind of complex communication system, which means that we are going to develop a prototype tool. And this prototype tool is going to accomplish three main things. Firstly, it's going to be domain specific, so specifically for banking. Secondly, it's going to provide all of these stakeholders with a common language to speak regarding fairness, but also mappings from fairness definitions, fairness practices to technical metrics, and then those are mapped to social contextual information. So that creates awareness as well. And lastly, what we will be doing is presenting all of this information in such a way that anyone within the system can actually read it and understand it. So we take care of the backend complex mappings, and they are simply guided towards what they need to be doing or what they need to explore. That was the end of my presentation. Thank you. If there are any questions, let me know.
A round of applause for Manisha. Yes, if there's any questions, please feel free to ask. Meanwhile, indeed, applause. You stopped sharing, that is wonderful. Then meanwhile, Bart can already start sharing his screen.
I don't need to, not yet anyways. I don't have any slides, but I do have a live demo.
Sorry?
I don't have any slides, but I do have a live demo. So I don't need to share my screen yet.
So no slides, but a live demo.
Yes,
so if we're all ready for it, so thank you, Manisha. We move on to the live demo.
Yes. All right. So my name is Bart van Oort. I'm a 25-year-old. I'm a software engineer by heart and by profession as well. I'm currently doing a master thesis at TU Delft and the AFR lab. The topic is about code quality and project quality for machine learning applications. And so we started off by doing an investigation to code smells in machine learning projects. We published a paper about it to a workshop co-located with ICAI. And one of the major findings of that paper was actually not really very much related to code smells, but more, we found that dependency management in these Python projects that we studied was pretty difficult. It was difficult to download all of the libraries that the project would use. And this actually led us to believe, or led us to the idea that just code smells and code quality is not the only thing that is important for a machine learning project. We should be looking at code smells a bit more holistically and try to define project smells instead. So that leads me to what I'm doing right now. Is I'm studying best practices for machine learning projects, based also on the work of Alex Serban and Joost Visser from Leiden University. And I'm creating a tool to evaluate the quality of a machine learning project by applying these best practices, by trying to find mappings from those rather theoretical, more high-level best practices that they have to more practical best practices. So to that end, I'm developing the tool called MLlint. It's open source, so you could even follow along if you want to at home. Now I will figure out how I can share the right screen. That should be this one. Yes, so you should be able to see a terminal now. Let me make that a bit bigger. And well, you start, of course, by installing MLlint. It's simply done through pip. And in order to see what kind of rules do we really evaluate here with this tool.
Is there a way to increase the font size?
Yes.
For old people like me who need glasses.
Is this large enough?
This is better.
Right. So the tool evaluates your project based on a number of categories. So these are related to version controlling, dependency management, but also code quality and data quality. These are not yet implemented, but they will be in the future. The idea is then that if you then run MLlint on your project, I'm running it on a simple test project right now, and you get a report saying like, okay, well, your project is using Git. That's nice, and it's also using a solution for version controlling your data. But you still have some things to do. For example, your project is not using continuous integration yet, and you have these things to work on. And if you want to, and the idea is also that this should help people to explore the tools, the software engineering tools that are available for helping you use, get a good quality project. So there is also help built in with recommendations on what you can do in order to fix these rules and implement the recommended software engineering tools. Now, where would this come in useful? How would you use this usually? Well, of course, you can simply use it like this locally to get an idea of what you need to do to improve your project's quality. But you could also run it in a CI pipeline. You could run it. It produces markdown output, so you can literally just put this in a comment on a pull request, for example. There's a lot to be done with that, and I hope that with this tool we can create an impact on the overall quality of machine learning projects, and to improve the software engineering knowledge and experience in the field of machine learning and AI. Thank you very much.
Wonderful. Thank you so much, Bart. Another round of applause. Are there questions for Bart about this work on software engineering for machine learning? If not, thank you so much, Bart. There is a question from Jorda, a general question. And the question is how the business value is perceived by industry, and in this case, I think ING then, of these lab initiatives, since business has a tendency focusing on short-term goals results. Well, so let me try to give an answer. I think maybe the answer should really come from ING, but I will try to give my perspective on this. I think for companies, a long-term relationship with a university is valuable for many reasons. So one is indeed for specific problems, find a specific solution, which then should be a short-term thing. But on the long term, focusing on the harder problems and trying to find meaningful answers there, that is what we do in research together with industry. And that is also valuable for a company like ING. And yet another perspective is, while, because the PhD students, that is a 4 or 5 year trajectory, but there are also master students where it's more like 9 months, or with bachelor students even 3 months. So then there is also the more short-term perspective involved. Does this answer the question, Jorda? Okay, thanks.
Yes, sorry. I didn't find the unmute button, sorry.
Good. Thank you, Jorda. Thanks for asking the question. I think in the interest of time, I would think we should close this one. If you have any further questions about what we're doing in Delft, please feel free to ping me either here or later in the Gutter Town, I think it's called. And Luis will be able to answer any question, Luis Cruz, any question about the ING lab, and the researchers themselves, the students, they also will be here. So feel free to contact them. Thank you so much and enjoy the rest of the day.